If you can solve a linear equation in one variable, then it's a small jump to be able to solve a linear inequality in one variable. Let's examine the difference between an equation and an inequality to understand this relationship. Here's the definition. A linear inequality in one variable can be written in the form ax plus b is less than 0, where a and b are real numbers. So the only difference here between this inequality and the equations that we were solving previously is that my equal sign has now been replaced with an inequality sign. It's important to keep in mind that this inequality sign can be a strict inequality, that is less than or greater than, or an inclusive inequality. That includes less than or equal to or greater than or equal to. So previously, where we had the equals, now we're going to replace that equal sign with any one of those four inequalities in the two categories, a strict inequality or an inclusive inequality. While a linear equation has one solution, like for example, x equals 2, a linear inequality has an infinite number of solutions. So an equation might have a solution that looks like x equals 2, where an inequality might have a solution that looks like x is less than 2. Now, there's an infinite number of numbers that are less than 2. So a linear equation has one distinct solution, while an inequality can have an infinite number of solutions. So instead of listing those solutions, we express these with what we call interval notation. So in this video, we're going to take the time to learn how to express the solution to an inequality actually before we solve an inequality. Couple of things to keep in mind as you learn interval notation. We're going to use open points and parentheses with strict inequalities. Now remember, strict inequalities are less than or greater than. And we'll use solid points and square brackets with inclusive inequalities. Remember, inclusive inequalities are less than or equal to or greater than or equal to. So with this in mind, let's just practice a couple of situations. Let's suppose that we solve an inequality. Now, we're kind of looking at the end of the problem here before we solve the inequality. But let's suppose we've solved the inequality and we got the solution x is greater than a. So x is greater than some number a. There's a couple of different ways, or three ways we'll examine here, where we can express the solution to this inequality. The first is called set builder notation. Set builder notation has a lot of important uses, but what it's going to feel like to us in college algebra is we're really just dressing up our solution. So the solution to the inequality is x greater than a number a, and we can see the heart of that solution right here. The rest of this stuff is just details. The first thing that you see here is a curly brace. Anytime you see a curly brace or a set of curly braces, that indicates a set, so a solution set or more than one solution. What you're going to see right here is the variable, and then this vertical bar represents the phrase such that. So to read this formally, we would say the set of all x such that x is greater than a. So that set represents every possible number bigger than the number a. To understand what that means, let's look at a number line graph. So a is going to be some real number located on the number line, and we've got it placed right here on our number line. We want to indicate the numbers on the number line that are greater than a. So notice we have the right side of the number line highlighted in blue. But at a, there is an open circle or an open point. Now remember, we said open points correspond to strict inequalities. So because of that strict inequality, we're going to put an open point at the end point of our graph. What that means is that we're including all of the numbers to the right of a, but we are not including a in our solution set. Now, to condense this information into one line, we use what's called interval notation, and this is what you want to master in this subsection. Interval notation is going to communicate the solution with two pieces of information. What's the leftmost value on the graph and what's the rightmost value on the graph. So clearly the leftmost value on our number line graph is a. So we have that right here. But because we're dealing with a strict inequality, we're going to pair that with a parenthesis. Remember, we use open points and parentheses with strict inequalities. So the leftmost value is A, but the parenthesis indicates I'm not including A, I'm just including numbers greater than A. And then the rightmost value on this graph, well, there's an arrow there that indicates that this pattern continues beyond the picture that we can see. The numbers bigger than A continue to positive infinity. So there's not really a rightmost value where that graph stops. It just continues increasing without bounds. So we call that infinity, and we're always going to use parentheses with infinity. So that interval of numbers says anything greater than A solves the original inequality. Okay, let's go through those details again with the next example. Suppose we've solved the inequality and our solution looks like x is less than or equal to b. To put that in set builder notation, we really just give it a suit and tie. We take that important information right here. We put it in curly braces, which indicate a set. We identify the variable here and separate the variable from the solution with that vertical bar. So if we wanted to read this out loud, we would say the set of all x such that x is less than or equal to b. Now, on our number line graph, let's suppose that b lives right here. So b represents some number on the number line. Notice at b, we have a solid point. This is because the original inequality was an inclusive inequality. So we're going to say b is part of the answer this time. If we want to indicate all of the numbers that are less than b, we would shade to the left of b. Now, if you look closely, in the first problem, the inequality pointed to the right, and we shaded to the right of a. Here, our inequality is kind of like an arrow pointing to the left, so we're shading to the left of b. Now, we want to condense that into interval notation using only two pieces of information. So I want to read my graph from left to right. I want to know what's the leftmost value on this graph. Again, the arrow indicates that the pattern continues indefinitely to the left. So we're going to say the leftmost value is negative infinity. That negative infinity is not a specific number. It just communicates the concept that the number line goes to the left forever. And anytime you have infinity, whether positive or negative, you use parentheses with an infinity. The rightmost point on this graph is B. And because there's a solid point on the graph, we're going to use a square bracket. So the square bracket says B is one of the answers to the original inequality, whereas the parenthesis says A is not included as part of the solution. Remember on the first one we had x is less than A? Well, A is not greater than A, so A is not part of the solution. On our next example, we had x is greater than or equal to b. B is greater than or equal to b. It satisfies the equal to part, so we do include it as part of the solution. Okay, let's look at one more variation. A is less than x is less than or equal to b. So we want to put this in set builder notation. Again, we're going to take our solution and dress it up a little bit. We start with a curly brace. Identify the variable. Notice the variable is here in the middle. Set of all x such that, and then our inequality, A is less than x is less than or equal to b. To illustrate this on the number line, we want to locate A and B on the number line. So I've got the A right here and the B right here. Now, closest to A, we have a strict inequality. So that means on our graph, we want to draw an open circle. Closest to B, we have an inclusive inequality, so we're going to construct a solid point there. And then notice our variable is in between A and B. So we're going to shade all the numbers in between A and B. So that's what the graph would look like. In interval notation, we're going to condense this down into two pieces of information, the leftmost value and the rightmost value. So the leftmost value on our graph is A. It corresponds to an open point or the less than strict inequality, so we'll use a parenthesis there. And then the rightmost value is B. It corresponds to a solid point or an inclusive inequality, so we'll indicate that with the square bracket. So this Solution set does not include A as one of the answers, but it does include B. So this is the end of the problem. When I solve a linear inequality in one variable, we'll express the solution in interval notation. But also moving forward, it's important for you to master interval notation because we'll use this to express the domain and range of a function in 2 dimensions as well.